Hello, in the last video, we had a look at an example where we were trying to find the values of P for which an equation had two real examples. In this example, let's have a look at a different, somewhat simpler in some ways, but somewhat harder in others. It's what I promised at the end of last video. So we've got x squared plus kx plus 1 is equal to 0. Let's work out what A and B and C are again. A is equal to 1. B is equal to K, and C is equal to 1. So that's nice and straightforward so far. But now let's have a look at what the discriminant looks like. The discriminant is equal to B squared, so it's going to be K squared minus 4AC. So we end up with K squared minus 4. Okay, so that's all right. We need to find solutions for values of K for two real solutions. So for two real solutions, two real roots, two real intercepts, x-intercepts, for two real solutions, delta must be greater than 0. Okay, so what we're going to do is the same sort of thing. We're actually going to graph delta as if it were y and k as if it were x. Okay, really important for you to get a sense of that we're talking about looking at graphing delta versus k as opposed to y versus x. And now we go about doing it. All we are really interested in is knowing what the shape of the graph is and what the and where the k-intercepts are. So for delta greater than 0, I'm looking for values of k such that delta is above the x-axis. All right, so let's have a look at it. So if I set k squared equal to k squared minus 4 equal to 0, I get k squared equals 4 and k is equal to plus or minus 2. Pretty simple solution. So that means that we've got a intercept at minus 2, 0 and another one at 2, 0. I'm not interested in working out the turning point. The turning point's not important, but the shape of the graph is. And because it's k squared minus 4, we've got a positive k squared there. The shape is a smiley graph. And so if I draw it, I don't care whether I've got the turning point in the right spot or not. The important thing to note is where in this graph is delta bigger than 0? Well, it's up here and up here. Okay, up here and up here. Everywhere along here can reach the graph, but underneath here, delta is negative. If I follow down the graph, I end up with a negative delta. Down the graph, I end up with a negative delta. So we can therefore conclude for two real roots, k must be less than negative 2, or k must be greater than 2. And you're done. That's basically it. Now, just as an added bonus, let me keep on going and say, well, what about for one real root? For one real root, delta has to equal 0. This has to equal 0. This has to equal 0. Where is delta equal to 0? Delta is equal to 0 at the origin here, and then if I go across, I can go to minus 2 or 2. So I would conclude that k is equal to minus 2, or k is equal to positive 2. And for no real roots, well, for no real roots, we know that delta has to be less than 0. Delta is less than 0. So there's delta. Delta is positive, 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 0. And now delta is negative. So everything between here and here are possible values for k. Everything between here and here will give us negative delta values. Okay, so k has to be between these two values. So for no real roots, this is how we write it. K is bigger than -2, but not equal to it, or less than +2. So that's how we write it. K is between -2 and 2. Okay, so although working out the discriminant was actually much easier, interpreting what it means by graphing is where it gets a little bit trickier.